Right, this is lesson 4 for the Year 10 booklet, but I am going to cover the first couple of pages in this as well. It's just my ordering isn't as good as Mrs. Wood's or Mr. Reese's. So this is in your booklet towards the beginning for atoms and then towards the middle-ish for symbols and formula. Okay, so work your way through that, looking at all the different lessons. So we'll start with atom structure. Now I know I've asked you in your booklet to label the nucleus, protons, neutrons and electrons. What you see here is that in the centre, in the small circle in the centre, the centre of an atom is called the nucleus. Now it's different in biology, so just be careful. In chemistry, it's the centre of the atom, and in the atom you have smaller particles called neutrons and protons. The protons have a positive charge on them. The neutrons don't have any charge on them. They're neutral. And in a bigger circle, which are called shells or orbits, which move around the nucleus, are electrons. And you can see the blue circles there have a minus sign inside them, so they're negatively charged. So it says at the bottom, electrons are found in shells around the nucleus and are negatively charged. They can move around the nucleus in the shells. And you can have more than one shell, but we'll keep it simple for now. We've got the nucleus. Outside the nucleus, we've got a shell. In the shells are electrons, and they can move around in an orbit, like planets orbit the sun. And inside the nucleus are neutrons and protons. And these numbers of protons, neutrons and electrons will differ with different elements. Another diagram just to show you, because you're going to meet masses of different ways these are drawn. So you've got protons inside, you've got neutrons, and this time they've done a key rather than labelling all the separate ones. Now you'll notice that this time you haven't got a little circle around the nucleus, but they're all clustered together. Protons and neutrons are found in the centre of the atom, which is called the nucleus. Protons are positive, neutrons are neutral, have no charge, and remember that the electrons are negatively charged. So you can also, and they like questions like this, try to identify the formula using an atom's key. Now, if you look at the common chemical compounds, you've got H2O, you've got NH3, you've got CO2, you've got H2O2. I wouldn't have expected you to know the formula for ammonia and hydrogen peroxide, but you could work them out. So if you look at water, we've got one big green atom and two small pink atoms. So in our key, the hydrogen is the pink atom, the oxygen is the big green atom. So it's H2O. And that's how it's drawn. A pink, a green, and a pink. Again, for carbon dioxide, CO2, you've got a small blue or turquoise atom in the centre, and you've got an oxygen atom either side. Right? So the oxygens will always look the same. The carbons will always look the same, the nitrogens. Now, different questions will have different keys. In an exam, they won't necessarily have colours like that, so they might have diagonal lines or a cross in it, or coloured in black, or just a single circle, right? So the key will be dependent on the question. Don't just think all hydrogen atoms will look pink here. This is just an example of a key. So I'm hoping that makes sense to you. They might also give you examples like this. Compounds are composed of more than one type of atom that are bonded, they're stuck, they're joined, they're chemically joined together. So you've got two or more elements that are chemically bonded together. So we've got H2O and we've got aluminium oxide, or a type of aluminium oxide. Now, if you look at the molecule structure, the red and the white circles, that matches. You've got three atoms there, a white, a red, a white, a white, a red, a white. So in H2O, you've got 3 atoms again. So it must link to that one. Now in the bottom example, you've got 1 aluminium with 4 oxygens around it. So you've got 4 and 1 atom in the center. So you've got 5 atoms altogether. So it must match that diagram. Okay, so it might show you that type of question. Then we look at whether something is an element, a compound, or a mixture. And we've got 9 different examples there. The first one is a compound because you've got different atoms joined together, chemically joined together. So it must be a compound. B, we've got molecules and atoms, but the atoms are all the same and the molecules are all the same. So it's a mixture of elements. They're not all joined together. They're separate, but the molecules are the same and the atoms are the same. C is a mixture of an element and a compound. The elements are just the pink circles. The compounds are the yellow and blues chemically joined together. But it's a mixture because they're not all chemically joined together. D is a compound. E is an element. It's molecules of elements rather than atoms of elements, but it's an element. F is an element, atoms of elements. G, a mixture of compounds, because you have 2 pinks and a blue, and you have a pink and a yellow. Now, they're both compounds, but they're not all chemically joined together. So it's a mixture of compounds. H is an element, all the atoms are the same, and I is a compound. Right, to work out the formula of something, you will be given this list of ions. And all you need to worry about is some are positives, some are negatives. And when you're working out the formula, you will have an element that will be positive and you will have an element that will be negative. Sodium chloride then. So if you're asked to work out the formula of sodium chloride, this is what I do. So you can imagine, or you can draw a seesaw on the side of your page. You can see the seesaw in the middle of the screen. Put the ions present in the compound on either side. So if you go back to the screen that I've just shown you, or you have this piece of paper in your exam or in a test, I will always give you a copy of this. Write the ions on either side. So it's asking me for sodium chloride. So it's Na plus Cl minus. I haven't learned anything. I just copied down from that list. You've got to make sure the number of positive and negative charges are the same on each side of the seesaw. Now, Na plus means Na1 plus. We just don't write the 1 in. Cl minus means Cl1 minus. Because each ion has the same size charge, so I've got 1 plus, 1 minus, the formula will be Na1, Cl1, and we always write the numbers subscript, which means at the bottom. But because we don't write in number ones, we can get rid of those, and it's NaCl. So that would be your formula for sodium chloride. Magnesium oxide. Draw the seesaw, or imagine the seesaw. Write in the ions. Magnesium Mg2 plus, oxide O2 minus. And when you're writing the ions, the numbers are superscript, they're above. Magnesium has a +2 charge, oxide has a -2 charge. Again, they're the same size. So the formula would be Mg2O2. But because Mg is 2 and O is 2, we can cancel the numbers down to MgO. So that is the formula of magnesium oxide. More difficult one now. Calcium chloride. Now this time we've got Ca2 plus and Cl1 minus, but I've had to write in another Cl1 minus because I have to have the same number of positives and negatives. So I've got Ca2 plus and I've got Cl minus and a Cl minus, so that is 2 minus as well. So it's they're the same size. 2 chloride ions are needed to make the number of positive charges and negatives equal on each side. So the formula this time is Ca, because I need 2 Cls, it's Cl2, and the 2 is subscript. Okay? Much more complicated one. Aluminium oxide. Because aluminium is 3 plus and oxide is 2 plus, you want to find the number that 3 and 2 goes into. Now the lowest number 3 and 2 will go into is 6. So if we make 6 pluses on one side, so I need 2 lots of Al3 pluses, and 6 minuses on the other side, so I need 3 lots of O2 minuses. So I've got 6 plus, 6 minus. The formula is Al2O3. Okay? Now there are examples in your booklet that I'd like you to do, and do your best, please. But just imagine or draw the seesaw. Just on a scrap bit of paper or in your booklet, that's fine.